11.1 and 11.2, areas of triangles and parallelograms. I realize that the notes in your packet are slightly different than the ones on this presentation, but they're close enough to each other that you can follow through. A rectangle, the area of a rectangle could be thought of as the following. If you call one of the sides of a rectangle its height, and the other side of its rectangle, its base, you can imagine splitting the rectangle into units of h. For each one unit of h would be a single unit, and there would be h of them. Then you can imagine taking the vertical distances and making b of those. So if you combine all of these little squares, unit squares, you would have h squares times b squares. Area of a rectangle is h times b, or base times height. Actually, usually we call it base times height, so why don't we just change it to b times h? We usually think about saying it that way, bh. A parallelogram is we can think of a parallelogram as having a height of h and a base of b, and if you take this piece off and insert it over here, you will actually end up with a rectangle. If I remove this triangle here and place it over here, you'll end up with a rectangle that has the property, the height is h and the base is b. The area of a parallelogram is also base times height. A triangle, we can think about it also as having a height component, which is its altitude, and the base would be over here. We could think about taking this triangle and doing a mirror image over here by reflecting it over itself. And if we did this, we would have a parallelogram that looks very similar to the parallelogram that we have over here that has a height of h and a base of b. But notice the triangle only contains half the area of the parallelogram. So, therefore, the area of a triangle is 1/2 base times height. Again, I know your notes are slightly different than these, but you can certainly fill in, the diagrams are the same and the area spaces are there, so you can fill in the pieces there. At the bottom of page 1 on your sheet, there are some choices. I think you might have, you have 3 choices and they're just in a different order. So if I take this triangle and I make a scenario like this, we have h and we have this whole thing as base. We could also flip it on its side, and we could think of this as being the height, which is the perpendicular distance from here to here. This would be the height, and then this would have to be its base. And notice these 3 triangles are all congruent. The third one would involve dropping an altitude from this third vertex here, and we'd have to have it go perpendicular to this third side. So this would now be what we call h, which would be an altitude that lives outside the triangle. And then the base for this guy would be b over here. Notice the area of all these 3 triangles would be absolutely congruent to each other. And it doesn't matter which you pick as h and which you pick as b, but at the end of the day, the area will be the same. If you turn the page, you will have, at the top of your page, you will have this information. a rhombus. Let's draw a rhombus here. A rhombus is a parallelogram that has 4 congruent sides, or all sides are equal. So it's a parallelogram, first and foremost, so we can use the general formula for a parallelogram, which is base times height. So base times height is one way to get a rhombus. The other way to get a rhombus is to think about is to do with its diagonals. So let's kind of think this through. So if its diagonals are x and y, that would mean each piece of the diagonals. Well, let's remember our properties of a rhombus. Well, we know all these sides are congruent. We know that its diagonals form a right angle. And so what is true about all these 4 triangles? Are they related to each other? Well, this has a length of 1/2 x. This have a length of 1/2 y. And so on, and so on, and so on. So by side, angle side, or hypotenuse leg, or however you want to think about it, all of these 4 triangles are congruent to each other. So there are 4 right triangles that have an area of each, well, actually, not an area, but here the height is 1/2 x and the base is 1/2 y. All these 4 triangles have the same, are congruent to each other. If I was to find the area of all 4 triangles, I would have to say, well, there's 4 of them, and I multiply it by the area of one of these triangles. Well, one triangle is 1/2 base times height. So, combining like terms, 4 divided by 1/4, 4 divided by 1/4 is just 1. So the area formula comes out to be 1/2 x times y. So another way that you can think about the area of a rhombus is 1/2 the area, the product of its diagonals. The diagonals were each x and y. You might want to write this. Another formula for the area of a rhombus is 1/2 times the product of the 2 diagonals. I'm going to erase this because I don't think you have this on. Nope, you actually do have this on your paper. Where does the proof fail for a parallelogram? So you might want to think about why this proof does not work for any parallelogram, and perhaps we can talk about what you said. So why don't you fill in why you think the proof does not work for any parallelogram? Why does it only work for a rhombus? We can talk about that tomorrow. Okay, now here we have some special right triangles. This is our favorite, 30, 60, 90. And this, of course, is supposed to be a 45, 45. Oh, this has to be 90 degrees, right, to make a triangle. So let's recall the following. What are the sides? Well, if this is 30 and this is 60, the side opposite 30 is going to be A, the smallest. The side opposite 60 is A root 3, and this, of course, is 2A. And again, with the 45, 45, 90s, if this is A and this is A root 2. A little review from recent memories. So, actually, I'm going to go back here. What's the area of this 30, 60, 90? It'd be 1/2 base times height, 1/2 A times root 3. So it's 1/2 A squared root 3. What about the area of this 45, 45, 90? Well, the area is 1/2 base times height. The base is a, and the height is a. So it's just 1/2 a squared. And of course, in a real problem, you don't have to memorize either of these, but just to recognize these when you see them. Here are some ways we can practice, and then we'll do a few together, and you will finish the remaining group for homework. So the hypotenuse of this 30, 60, 90 is A, is 8. So the side opposite 30 is the smallest, 4, and this has to be 4√3. The exact area of this triangle ABC is 1/2 base times height. 4 divided by 2 is 2. 2 times 4√3 is 8√3. This triangle here is 13, 13, and 24, but this is not a right triangle, so we have to drop an altitude here and see if we can remember our properties of isosceles triangles with an altitude. Well, each of these must be 12, so we'd have to find out what this altitude is by doing Pythagorean. If you take 13 squared, subtract 12 squared, you'll get 25. The square root of 25 is 5. So this has a height of 5. So the area of this triangle will be 1/2 5 times 24. 5 times 12 is 60. 60 units squared. How about this triangle here? We want to find ABC, which is this piece over here. If we could find the whole triangle and this little piece, we could subtract out to get the leftover. So let's go ahead and do that. Well, can we find this here by doing 10 squared minus 6 squared to get x squared here? This would be 100 minus 36, which is 64, and the square root of 64 is 8. So this becomes 8. Then we can do Pythagorean to get this whole business here. So let's do it. We get 17 squared is equal to 8 squared plus the entire, shall we call it y? Y squared. If you do that out, you're going to get y equals to 15, the whole length of this whole side. We only are interested in this little part here. This part from 15 and 6, this would have to be 9 units. So to find the area of this triangle, we could do 1/2 base, which is 9, times 8, which is the height. 1/2 base times height. 36. Exact area. So for this one, we see these are 60 degrees, which means, of course, all these have to be 10. If you want to find the area, you'd have to find what this is, h, and I'll give you a hint. This is 5, because that's half of the base. And you can do some Pythagorean theorem, you can solve for h, and then you can find the area of that triangle here. On the top of your next page, you have this exact picture here, and they want you to find the exact area of this parallelogram. Well, if this is 15, this must be 15, this must be 10. We could drop an altitude here, and can you find this length here? If you can find this length here, then you could do the parallelogram formula to find this one. This has diagonal lengths 40. Maybe we call this diagonal length x, and this is diagonal length y. One of the formulas you learned on the other page was the area is 1/2 x times y. So it would be 1/2 40 times 6.25. So you can finish that off.